Welcome to the journey through Faraday's law of electromagnetic induction. We're about to uncover the secrets behind this fascinating phenomenon. Faraday's law states that when there's a change in magnetic field within a closed loop of wire, it induces an electromotive force, EMF, causing an electric current to flow. This can be mathematically represented by the equation EMF equals N times d phi by dt, where EMF is the electromotive force, phi is the magnetic flux, and dt represents the change in time. Now, let's see what happens when we move a magnet parallel to the coil. There's no change in magnetic flux because the magnet's field lines are parallel to the coil.
Result: no voltage induced. Now, let's change the magnet's direction and move it perpendicular to the coil. This time, we see a change in magnetic flux as the magnetic field lines cut across the coil. Result: voltage is induced. But what about the direction of the induced current? We can use the right-hand rule to determine the direction. When the magnet moves into the coil, the induced current flows one way, and when the magnet moves out of the coil, the induced current flows the opposite way. This will be covered in detail in next lecture. The induced current in a coil is dependent on the more turns or loops of wire a coil has, the greater the induced current will be. This is because each turn contributes to the overall magnetic flux change. When a magnetic field cuts across the coil, it induces a voltage in each turn of the coil, and these voltages add up. In other words, the total induced voltage, EMF, is proportional to the number of turns. The strength of the magnetic field also plays a role. A stronger magnetic field will induce a greater current in the coil, assuming other factors remain constant. According to Faraday's law, the rate at which the magnetic flux changes is a critical factor. If the magnetic field changes rapidly, it induces a larger current in the coil. This change in flux could be due to the movement of the magnet or a change in the strength of the magnetic field.